Students, welcome to our series once again. I will request you all to do subscribe the channel and like the video if it's helpful to you people. See, let's start with the questions. See, we are already done. Those who will be watching this video for the first time for this channel, I will tell them that we are already done with the chapter of straight line. One practice session, one practice paper, not the session, practice paper and the solution for like straight line mains level question, and the one was for advanced level question. Now we are going to start with circles and circles. See, I found several many questions which I really found to be relevant and appropriate. So I divided it into two parts. So mains will be having two parts, 10 questions each. Okay. So let's start with the part 1 of circle, questions related to circles for mains level examination. So the first question is ABCD is a square of unit side 1 unit, of course that's missing. P and Q lie on side AB and R lies on the side CD. The possible values for the circumradius of triangle PQR is. So ABCD is a square, so this is B, of course, then this is C and this is D. So C, D, and then that's it. So this is 1, 1 unit side square. Now see, P and Q lie somewhere on AB and R lie on somewhere on CD. Now, of course, we will get a triangle. So the circumradius, the possible values, that means we need to know the range. We need to know the range of the circumradius of this triangle PQR. See, the largest circle possible for this triangle is the one for which here is P, here is Q, or R is here or it's here. Why? Because see, in blue color, if I consider this to be the triangle, then its circumcircle is the circumcircle of the square itself. You can't have any circumcircle for such a triangle PQR under the given condition which is larger than this, because of course P, Q and R are the vertex on the sides of the square. So of course the circumcircle of the square is the largest possible circle, and its radius, the circumradius of for this square or for this extreme triangle is I think root 2 by 2, no? So that's root 2. So that's the largest possible value, and 1 by root 2, I'm sorry. So it's 1 by root 2. So we will see how much is it. I think it's 1 upon 1.414, that will analyze. Okay, now see, then the smallest possible value is, see, the smallest possible value can be something like, if we go for the in circle. If we go for the in circle, this is the radius of this circle. Okay, which is 1 unit. Now you can't have a triangle whose two vertex lie on the sides of the triangle such that it is a circumcircle, because it touches the side once only. Okay, so the minimum possible value is 0.5. So it has to be greater than 0.5. Macho, it has to be greater than 0.5, isn't that? Because see, if this is point R, let's say this is vertex R here, and you need to have PQ, then it should intersect the line segment AB. Okay, so greater than 0.5 and less than equal to 1 by root 2. Now 1 by root 2 is like, if I square it, then it's 1 by 2, which is 0.5 under root of 0.5. Okay, so under root of 0.5 is something 0.7. Yeah, so it's greater than or less than or equal to 0.7 ... So that means it can be 0.7, the circumradius can be 0.7, the circumradius can be 0.6. It can't be 0.5 according to me. So for me the answer is B part and C part. Okay, so see, I will request you all to keep sharing the answers. If you are watching the video and you have any other idea, then you, because see, why am I telling you? Because according to me, if I remember it correctly, from the answer key, see, these are all the questions which I selected from one or the other source. Okay, so I am spending a lot of time in selecting these questions so that there might be something new which you get in those questions, and they are relevant questions also. Okay, so of course I prepared the answer key also because Our students here at here in our campus here in Toronto, they are also solving these questions. Okay, so as far as I remember, the answer marked was A, B and C, but according to me now when I'm solving it, the answer should be B and C. Okay, so if anyone disagree, you may let me know with the help of comment box. So moving to the second question, the circle this does not intersect or touch the coordinate axis. Okay, and the point 1 comma 4 as its interior point. See, when will a circle won't touch or intersect the coordinate? See, if it touches, chaliye, let's consider the extreme case, it touches the coordinate axis or just one axis. So if a circle touches, let's say, x axis, then what? So that's the center minus g comma minus f, and that's the radius. So if a circle touches the x axis, then radius of the circle should be equal to the ordinate of this center of this point, because ordinate of a point is its distance from the x-axis. Okay, so this should be equal to that one. So squaring both the side, we know center is g square plus f square, sorry, radius is under root of g square plus f square minus c. Squaring it, so g square plus f square minus c should be equal to f square. So that's the condition. Similarly, if it touches the y-axis, the same case, r should be equal to abscissa of the center. So that's the extreme case. So now, if it doesn't touch or intersect the circle, the axis, the circle doesn't intersect or touch the axis, what does that mean? That means radius should be less than both the cases. Okay, and radius should be less than mod of g also. So that's one condition. Now the center is 3 comma 5. So that is for sure that radius should be less than 3, because if it's less than 3, it has to be less than 5. Okay, if it is less than 3, it has to be less than 5. Now how much is radius? So radius is under root of g square plus f square. So 9 plus 25 is 34 minus c, and this is less than 3. So squaring both the side, we get 34 minus c is less than 9. So c is greater than 25. That's one case. And one another thing, the point 1 comma 4 lie inside the circle. Okay, so 1 comma 4. So if a point has to lie inside the circle, so what you have to do, you have to just substitute the coordinates of the point in that equation. So it's minus 6x minus 10y plus c. So you have to get S1. What is it? So replace x by abscissa of the point, y by ordinate of the point. So 1 plus 16 minus 6 minus 40 plus c, and that should be less than 0. This should be less than 0, then only, or c, or otherwise you can just simply use the geometry. So if 1 comma 4 lie inside the circle, then its distance of the center from this point should be less than r. That's how you will get this condition. Okay, so just solve it. So c should be less than 46 and then 17, so 29. So c is greater than 25, less than 29. So yeah, that's it. So that's the answer. So A option is should be the correct answer here. So that's it. So that was a simple question based on analysis of the position of a circle with respect to the axis. How will we judge whether it intersects the axis, it touches the axis, or neither of it, and the position of a point with respect to the circle. Now moving to the next one, the circle after being reflected on the line. See, that's a very important mirror line. Okay, line mirror rather. Y is equal to x. So let us say that's the circle x square plus y square minus 8x minus 10y plus 37 equal to 0. So its center is 4 comma 5 and its radius is, so what's the radius? Radius is under root of 25 plus 16, so under root of 41 minus 37, which is 2. So its radius is 2. Okay, now see, if you reflect it on the line, y is equal to x. So the center, see what will happen is, let's say that's the point 4 comma 5. See, nothing is the shape, of course it will remain a circle. The image of a circle on the mirror has to be a circle, and moreover the size of the circle will also remain same, isn't that? Is the size going to change? Nothing is going to change. The only thing which will change is the position of the circle, that means its center. So just take its mirror image on the line, and this is 5, 4. So the new circle is this one with radius is equal to 2 unit. I think all of you will agree to it, and that's on the line y is equal to x. Okay, so image of alpha comma beta on the line y is equal to x is beta comma alpha. So that's it. Now moving to the next step, parallel. Now it's shifted to root 2 unit towards the origin parallel to this line. So this is shifted towards the origin parallel to the line, 2 root 2 units. See, we have already seen this, that if you move along the line whose slope is +1 or -1, so along that line, or any line which is parallel to that line. Now if you move by root 2 unit, that means you move down or up. That means you move along the x-axis by 1 unit and along the y-axis by 1 unit. See how? Let's say this point is 1, 1. So of course this distance is root 2. Okay, so you are moving from here to here, so this is 1 unit, you are moving down 1 unit and moving towards left 1 unit. So I am again repeating, we have already used this in one of the question in straight line, that if you are moving along a line which is parallel to y is equal to x, slope +1 or -1 by root 2 unit, that means you are moving 1 unit along both the axes. So you are moving 2 root 2 unit, that means this point is nothing but it is 2 units towards left. Okay, so 3 and 2 unit down, 3, 2. So that's the circle. So the circle is x minus 3 whole square plus y minus 2 whole square, and then is equal to, radius remains same because you are just shifting the circle, so it's 2 square, which is 4. Okay. Now then the equation of the radical axis of the given circle and the new circle is, so let's first write it. So x square plus y square minus 6x minus 4y and then plus 9 equal to 0. So that's the equation. Now what is radical axis? See, if there are two circles, s1 equal to 0 and s2 equal to 0, then equation of radical axis, I represent it as capital R dot capital A dot, is given by simply s1 minus s2 equal to 0, where you have to ensure that the coefficient of x and y in x square and y square in both the circle has to be same, because that's a line. Radical axis is a line. Okay, so there can't be any second degree term. It has to be a linear equation. So x square y square term must get cancelled. Okay, and how do we define it? See, some of you might be thinking that how to define radical axis. So radical axis is defined as the locus of a point which moves such that the tangent drawn from it on both the circles. So it's defined only and only for a pair of circle. Okay, so length of tangent drawn from it to both the circle is equal. So these two lengths are equal. Okay, so that's how we define radical axis. So now that's simple. So you have to just subtract the second one from the first one. So it's minus 8x. So shall I do it here? Minus 2x here, and then plus minus 6y here, and then 37 minus 9 is how much? I think 28 plus 28 here. So it's x plus 3y minus 14 equal to 0. So that should be the answer. So x plus 3y, A1 is the option here. So that should be the answer. So that's done. Moving to the fourth question. You see, fourth question is an important one. Intersect orthogonally. What does that mean? Two curves intersect orthogonally when the angle between the curves is right angle, it's 90 degree. Okay, and how do we define angle between any two intersecting curves? So if two curves intersect, then the angle between their tangents at the point of intersection is defined as the angle between the two intersecting curves. Okay, so orthogonal means they intersect at right angle. So if the two circles intersect at right angle, so that means, let's say that is the case. So if two circles intersect at right angle, that means tangent to the one is the normal to the other. See, we know normal. No, see, normal is a line which is perpendicular to the tangent at its point of contact, and we know from class 10th theorem that normal will always pass through because at the point of contact, if you draw perpendicular to the tangent for a circle, it will always pass through the center of the circle. So normal of a circle will always pass through the center of the circle. So okay, so that's why I said this is it. Now, so It's a very important case. See, this is R1, let's say, radius R2, and that's it. So it's a Pythagoras type of thing. So C1, C2. C1, C2 is nothing but under root of R1 square plus R2 square. Now let's move to the question part. So I took up this question just to share this geometrical aspect of this circle and this orthogonal condition, the length of their common chord. Okay. So that's the common chord. So what is common chord? The chord joining point of intersection of two curves is called the common chord. So that's the common chord. So it's P, Q, and this is our M. Now, I think all of you must be knowing it that PM is perpendicular to the line joining the centers of the circle. You can easily prove it with the help of congruency, and these two angles are supplementary. I mean, I'm not going into its proof, it's not required here, okay, but we all should know it. If you don't know it, now don't forget it from here on, okay. Now see, right, see, I will just write the area of this triangle. Area of triangle PC1, C2. So we have two ways of writing it. Half into R1 into R2, because it's a right angle triangle, half base into height, and then another one is half base into height. So half base is C1 C2, which is under root of R1 square plus R2 square into height. Height is how much? Height is PM, which is PQ by 2. That's one more interesting thing. This has to be the midpoint, because we know if a center, from the center, if you draw perpendicular to a chord, it has to bisect the chord. So that's it. So this is gone, this is gone. So PQ is nothing but 2R1 R2 upon under root of R1 square plus R2 square. Geometrical properties of for circles are going to be extremely important, bachcho. Whether it's a JEE mains paper, it's an advanced paper, BITS, MSAT, whichever paper it is, you shouldn't forget that the geometrical properties of triangle, the similarity condition, congruency condition, circle, all the theorems which you people would have done in your 10th class, 9th class, they are going to be extremely important. Likewise, the parallelogram, the quadrilateral properties, okay, in particular the parallelogram. Now moving to the fifth question, the equation of a circle touching the line at a distance root 2 units from the origin is. So okay, so how do we draw the curve of mod y is equal to x? So you can draw it by using two cases, like it's y is equal to x when y is greater than equal to 0. So y greater than equal to 0, y is equal to x, because you have to consider only that part for which is there for y positive. Y positive means above the x-axis, and this is minus y is equal to x when y is negative, and minus y is equal to x means it's x plus y equal to 0. So again, for this one you have to, this is x plus y equal to 0 line, so you have to consider this part only, because y is negative, so below the x-axis, the part of the curve which is below the x-axis. So that's it. Now there is a circle, see, both are inclined at an angle 45 degree, so that means x-axis is the angle bisector. So again, we should remember that whenever for a circle, whenever you draw a pair of tangents from an external point to the circle, the line joining this point with the center has to be the angle bisector. You can very easily prove it using congruency here again, okay. So that's it. You can very easily do it. So that's the angle bisector. So that means the center of the circle will lie on this x-axis only. So how will it help me or help us? It will help us because if I have to assume this center, I will assume it as p comma 0. So there's only one unknown. Now at a distance root 2 unit from the origin, see, at root 2 unit, again the same thing. You are moving from origin, so we are moving from origin root 2 units along which line? Either y is equal to x or y is equal to minus x. That means what? We will move 1 unit along the x-axis, 1 unit along the y-axis. So we directly know this point, and this is 1 comma 1, and that's it. So what do we need? So we just need what the equation of the circle. So if we get p, we have the answer. So what can we do? So that's it. That's the theorem. So just equate it, and this slope is 1. So this has to be minus 1. I think we got it. So 1 upon y2 minus y1 upon x2 minus x1 is equal to minus 1. So p minus 1 is equal to 1. So p is equal to 2. So that's it. And then it's 2 comma 0, and this is okay, 90 45. It has to be 45. They are equal. So this is also root 2. Radius is root 2. So it's x minus 2 whole square plus y minus 0 whole square is equal to 2. So x square plus y square minus 4x plus 2 equal to 0. That should be the answer. I think I am done. But all of you would have understood. Every question has something to remember if it's new to you people. Okay, those who know it, definitely this is a mains level practice question paper, so that might be a bit simple for few of you or several of you, but for others it might be really very useful, because these are very small things which you shouldn't forget. Okay, for the circle, the geometrical properties extremely important. Again and again I'm repeating that point. Now if the circle passes through all the four quadrants, see, when will a circle pass through all the four quadrants? The simple direct condition is it will happen only when origin lie inside the circle. No other condition is required. I am repeating, it will happen only when origin lie inside the circle. So origin lie inside the circle, so you just replace x and y by 0, 0, and we have seen in like few questions back that when a point lie inside the circle, s1 has to be negative. So what will we get? A mod of sine theta. Okay, that's an identity, isn't that? Less than 1. Okay, not an identity, because it can be equal to 1 also. So theta can be r, is okay, not belongs to r. Okay, no, theta is an integral multiple of q. What does that mean? No, I don't think. I think none of these should be the answer. See, it's true for every theta. The only thing is equal to 1 will be a problem. So theta can't be the integral multiple of pi by 2. Rather odd multiple of pi by 2. For rest of the cases possible, so there is no such case, so none of these is the answer. So moving to the next one. Three parallel chords of a circle have lengths 2, 3 and 4. The interesting question. Okay, have length 2, 3, 4 and subtend an angle alpha. So let's say this is, I'm not drawing it here, so because I will be drawing it. So two parallel chords 3 and 4. They are parallel chords, okay, subtending at the center angle alpha. Then the second one, which is of length 3 unit, beta. And then the third one, which is of 4 unit length, the chord. This angle is alpha plus beta. Okay, see, I tried solving this question with this figure. Okay, but it really went so long, and I couldn't conclude. Actually, it was the calculation part was getting so long, so I just left it. Then after few days, maybe I don't remember, but maybe after 1 or 2 days, I again started tried to solve this question. Then I realized, see, there's a theorem. So what the special thing is, there's no requirement of these parallel chords. So 2, see, the important thing is 3, 4. Okay, so you can always have a triangle. Fine, 2, 3 and 4. Now that's it. See, very simple thing. Alpha, 3 unit, beta, and then for 4 unit it's alpha plus beta. Okay, now see, so what? We have to get here cos alpha. So alpha plus beta is less than pi, is fine. So this is 3 and this is 4. Now we need cos alpha. Okay, now 2 unit. This chord subtend angle alpha at the center. So it will subtend its half at any point on the major arc. So for this chord, this is the major arc. So angle subtended by a chord at any point on the major arc is half of the angle which is subtends at the center. So it's alpha by 2, and this is the triangle whose all the 3 sides are known. So applying cosine rule, cos alpha by 2 is sum of square of sides. So 25, 16 plus 9 is 25, minus the square of the opposite side 4 upon 2 into product of adjacent sides 4 into 3. So cos alpha by 2 is 21 by 24, so it's 7 by 8. Okay, so we need cos alpha. So now we have that relation. So cos 2 theta is 2 cos square theta minus 1. So that's it. So 2 cos square 49 by 64 minus 1. So 49, 98 minus 64 upon 64 is 34 upon 64, which is 17 by 32. So that should be the answer. Again, a question which I could do it with the help of the geometry and the theorem which we all have done in our like previous classes, like 9, 10 classes. Okay. Now moving to the 8th question. A and B are 2 points on xy plane which are 2 root 2 unit distance apart and subtend an angle 90 degree at the point 1, 2 on the line. So that's the line x minus 1 x minus y plus 1 equal to 0. There's a point C here, 1 comma 2, okay, and there's a segment somewhere AB. So that's a fixed segment of length 2 root 2 and its subtends right angle 90 degree, which is larger than any angle subtended by the line segment AB on any other point of the line, which is larger than any other angle. Okay, now see what is the possibility. Okay, then find the equation of the triangle through the point A, B and C. So see, this angle is 90 degree. So this segment can't subtend any angle which is more than 90 degree on this line. See how I saw it, was I just said, okay, if I consider a circle, see there's an equation of family of circle, the equation of family of circle touching a given line at a given point, and what is it? So we assume a point circle, that means a circle whose center is the point itself 1 comma 2 and radius is 0. Okay, so s plus lambda times the equation of line. That's it. So this gives us all possible circle which touches this line at this point. Now among these circles, see why will it be circle? Because the circumcircle, of course this angle is 90 degree. So a triangle, any chord subtends a right angle only when the chord is the diameter of the circle. So this chord has to be the diameter. Doesn't seem to be a diameter, but okay. So AB has to be a diameter, bachon. And then in that case, this has to be a this will be a what? This will be a tangent. Why so? Because see, if it's not a tangent, then the angle will be lesser than this one. Okay, so angle will be less than 90 degree for sure. So that's the circle. So now let's write the equation. So x square plus y square and then x times lambda minus 2 minus y times lambda plus 4 and then this is plus 5 plus lambda equal to 0. Isn't that? Okay, now we need its radius. So what will be the radius? Radius is under root of g. G is half. So lambda minus 2 by 2 whole square plus lambda plus 4 by 2 whole square and minus c 5 plus lambda and its root. So I'm not putting its root, so this is nothing but 8, squaring both the sides. So again I'm repeating, I just wrote its radius, and radius has to be not 8, I'm sorry, that's the diameter. Okay, so it's root 2, so it's 2, it will be 2, isn't that? So it has to be 2 there. Okay, so now just solve it. So it's lambda square 2 lambda square plus 20 minus 4 lambda plus 16 lambda minus 20 lambda and then minus 4 lambda rather, right, and then minus 20 is equal to 8 after taking LCM whatever. So it's 4 lambda 8 lambda, I'm sorry. Okay, that's gone. 20 gone, really good. So 2 lambda square is equal to a, so lambda is nothing but plus minus 2. So these are the two possible circles. Okay, so for lambda is equal to 2 and for lambda is equal to minus 2, you can have such two circles, and that's it. Okay, so you will get the answer. So that's why equations of circle. Okay, so that's it. So that's how I tried this question. Of course, as I again and again repeat, if you have any other idea which might be definitely better than this one, so please do share it with me. Moving to the ninth question. Ninth question is the exhaustive range of values of A such that the angle between the pair of tangents drawn from AA to the circle. So the circle is x square plus y square minus 2x minus 2y, I think minus 6. Yeah, minus 6 equal to 0. So that's the circle whose center is 1 comma 1. So center is 1 comma 1, A comma A. Again, both of them lie on y is equal to x line. Might not be useful. And again, see, I just keep myself alert while solving questions. Okay, so keep analyzing whatever information is given. Now, tangents are drawn from here. And what is it given? The range of the angle, that angle between the pair of triangles 5 by 3 to 5. See, again, we know that these two triangles are congruent. So if this is theta, so this is theta by 2. If this is theta, so theta lie in the range pi by 3 to pi. So that means theta by 2 lie in the range pi by 6 to pi by 2. Fair enough. Now, this radius is known. Yeah, it's known. So how much is it? So 6 plus 2 is 2 root 2. And this distance is also known. And this length is, which is the hypotenuse here, which is 2 root 2 times a minus 1. Of course, I will put within mod. Okay, so that's the length. So now I will use sine theta by 2. Sine theta by 2 is 2 root 2 by 2 times mod of a minus 1. I think it was root 2 times, isn't that? Yeah. So that's gone. So it's 2 upon mod of a minus 1. Bachcho. Theek. Now what? See, theta by 2. Now the maximum value, it will be 90 when the point a comma a lie on the circle. First thing. And the minimum value is pi by 6. So that means, and see, sine theta, sine of any angle, and any angle means between 0 to pi by 2. It's an increasing function. Okay, so that means 2 upon mod of a minus 1. If it's sine pi by 6, because theta by 2 minimum value is pi by 6, and as I said, sine is an increasing function for theta or for the angle between 0 to pi by 2. If you look at its curve, so that's the curve of sine. So from 0 to pi by 2, it is continuously increasing, and the range of theta by 2 is from pi by 6 to pi by 2. It's an increasing function. So the minimum value will be when it is sine pi by 6, so it is half, and the maximum value will be when it is 1. Okay, so that's it. And see, maximum value will be when a comma a actually satisfy the circle. So let's solve it. So mod of a minus 1 cross multiply this one. So what we will get? So mod of a minus, since it's positive, we can cross multiply in an inequality only when the denominators are positive. So everything is positive. So it's less than equal to 4. So that means a minus 1 is less than equal to 4, greater than equal to minus 4. So a lie between minus 3 to 5. First guess. Now solve this one. So what does that give us? So that gives us mod of a minus 1 is greater than equal to 2. So in that case, either a minus 1 is greater than equal to 2, so is greater than equal to 3, or a minus 1 is less than equal to minus 2, so is less than equal to minus 3. So minus 1, I'm sorry, minus 1. Now we have to take the intersection, because both the conditions, this is the AND situation, because this lie between half and 1. So half and 1 is greater than equal to half and less than equal to 1. So AND condition leads to intersection. So when you take intersection, so it will be minus 3 to minus 1 union 3 to 5. Okay, so that's it. So the angle are open. So it's an open interval. So that's why I left it open. So minus, what was that? Just a minute. Minus 3 to minus 1 union 3 to 5. Minus 3 to minus, that's it. So D option is the correct option according to me. So now moving to the last question. Last question is, if a line means the coordinate axis in and B, a circle is circumscribed about triangle OAB, the distance from AB to the tangent, of course it's not given, but in that case, see, if it's not given, even then also, though in every question they will mention in the examination, O has to be the origin, okay. So I'll take it because a line means the coordinate axis at A and B, O has to be the origin. So the distance from A and B to the tangents to the circle from at the origin, B, M and N, that the diameter of the circle is, so that's the situation. So that's the situation. So of course that is the diameter, okay. So if I say this is A comma 0 and this is 0 comma B and vertex A, this is origin, and say this is the tangent to the circle at the origin. So if this is the tangent to the circle at the origin, so that's the tangent. Question is, the length of perpendicular drawn from here A to the tangent is of M unit, from B to the tangent is of N unit. We have to find diameter in terms of the length M and N here, okay. Okay, fine. See, Achha, we can think something else also. See, otherwise what I thought initially, let's use it. So, equation of the circle, it passes through origin 0, 0 and the center is a by 2, b by 2. So, it's like x square plus y square minus ax minus by equal to 0, isn't that? Now, if I have to find the equation of tangent to this circle at origin, so it's capital T equal to 0, I believe most of you must be familiar with that. So, equation of circle, equation of tangent to the circle at the origin. So for any conic, whenever you have to write equation of tangent to any conic, be it a circle, ellipse, parabola, hyperbola, at any point, we use capital T equal to 0. Since the point is 0, 0, this is gone, it will be minus a by 2, x plus x1, which is x plus 0, minus b by 2, y plus y1, y plus 0 is equal to 0. So it's again ax plus by equal to 0. So now, its distance from a, 0. So m is a, so it's a square upon under root of a square plus b square, and this n is distance of this point from the line, so 0b, so it's b square upon under root of a square plus b square. Okay, now let's talk about this diameter. Diameter AB is under root of a square plus b square. So if I add just m and n, just add them, so since you have same denominator, numerator will add up and they will give, that will give us to give nothing but under root of a square plus b square, which is the diameter. So I think we are asked about the diameter of the circle, so that's the answer. Okay, so now if we try to explore the other option, why? Because few of you may say that writing capital T or using capital T might not be in the syllabus, so how to do it without it? So we can use some projection type of thing also, no? For that, see, that's a trapezium, okay? So we will get this length, we have its slope, and then wait, what we can go for is projection of this length on this length won't be the case, that is this distance. See, we have to, that will be a lengthier process. See, we can always have this line also, because it is perpendicular, then we can find this point, because we already, but for that we use capital T equal to 0, okay, tendency condition. Just a minute. I think we can use similarity condition also. Okay, so chaliye, I will think on it, because thoda figure utna acha bana nahi. If they meet somewhere here, they are all perpendicular. Let's say this is O. Then triangle ORB is similar to triangle OQC. Similarly, ORB is similar to OPA. Okay. And these three lines are parallel also, no? Chaliye, people should also try. I will also try once I finish this session. OB upon OA, let's say, for this triangle and this triangle will be equal to N upon M. Fine. And similarly, OB upon OC will be equal to, okay, this is also radius, no? BC will be equal to n upon under root of a square plus b square by 2. Okay. Now here I think we can do it. Why? How? Because see, if I just reciprocate it, OA upon OB is m by n, and OA can be written as OB plus AB upon OB is equal to m by n, and this is 1 plus AB, that's what we need, upon OB, so that's gone, so m minus n by n. Okay, that's one relation. Now here in this case, OB is OC, okay, again reciprocated, OC upon OB is under root of a square plus b square by 2n, isn't that? Now I can write OC as OB plus BC, BC is half AB, so AB by 2OB is equal to that's one again. So AB by 2OB is equal to under root of a square plus b square by 2n minus 2n. Chaliye, yeah. Okay, so if I take 2 here, so that's gone. Now this is equal to this, so m by n minus 1 is equal to under root of a square plus b square by n minus 2. So we need under root of a square plus b square, isn't that? So this is like, if I bring it this side, m plus n by n is equal to under root of a square plus b square by n. This is gone and we got it. That's it. Okay, so that's what I said. We can try geometry also. So chaliye, ye ho gaya. So chaliye, we will end it here. We'll be coming with the second part, and then followed by it will be the advanced practice, advanced level practice paper here, bachcho. Chaliye, so stay connected, keep solving the questions. With all the best wishes, we will end here.